In this video, I would like to explain the concept of equivalent rational numbers. Equivalent rational numbers. What do we mean by this term equivalent? Rational numbers, what are rational numbers we have seen in the last video. If not, I would like you to see that video first and then come to this video. So let's start with an example. Let's say that I have 2 upon 4. Let's first try to visualize this. What does this actually mean? So let's say that I have a big chocolate bar, something like this, and I divided this into 4 equal parts, 1, 2, 3 and 4. So out of these 4 parts, this is the 4 that we are talking about, 4. So I have divided this chocolate into 4 parts, as you can see here. Now the numerator is 2, which means we are talking about 2 parts out of these 4 parts. So if I would shade, let's say this is the first part and this is the second part. So this portion represents 2 out of this entire 4 portions, that is 4. That is the meaning of 2 upon 4. How else can we represent this? I'll do one thing. Let me divide this 4 parts again into halves. What I mean is that this is one part and I'll again divide this into 2 equal halves. Similarly, this part I'll again divide into 2 halves. This part again into 2 halves and this again into 2 halves. So now if I would ask you, how many total number of parts do we actually have? So 1, 2, 3, 4, 5, 6, 7 and 8. So we have divided this chocolate into 8 parts. Initially we had only 4 parts, but same chocolate we have divided into 8 equal parts. Now if I would again ask you, how much portion of these 8 parts are represented by this shaded region? This first part is shaded, so 1, let me use some different color. Okay, I'll use white. So this first part is shaded, second part is also shaded, third and fourth, both of them are shaded. So this means that if I am changing nothing, I have actually shaded 4 parts out of these 8 equal parts. And just remember, I haven't changed anything. The shaded part are still the same. It just depends on number of divisions that I make. So now out of 8 parts, I actually have shaded 4 parts. But this division, this portion that I'm talking about is same, irrespective of if I divide it into 8 parts or if I divide it into 4 parts and so on. So using this scenario, using this figure, can I say that 2 by 4, 2 portions out of 4 portions is actually equal to 4 portions out of 8 portions? Because this is what we actually saw here. This is the concept of equivalent rational numbers. So this is how we can understand this pictorially. There is an algebraic way to do this. And what's that? Answer me this. How can I get 4 from 2? I need to multiply this by 2. 2 times 2 is 4. So if I would multiply denominator again with the same value, I would get 8. 4 times 2 is 8. So this means that if I would multiply numerator and denominator with same quantity, the value of the fraction remains the same. So that's why 2 by 4 is equal to 4 by 8. Let me take another example. Let's say that I have 3 upon 7. So if I would multiply numerator by, let's say, 4, so I have to multiply denominator with the same quantity 4. So this would give me 3 times 4 is 12 and 7 times 4 is 28. So 3 upon 7 and 12 upon 28 are equivalent rational numbers. And I could do anything. Instead of multiplying this by 4, 3 upon 7, I could have multiplied this with, let's say, 2. But I have to multiply both numerator and denominator with the same value. 3 times 2 is 6, 7 times 2 is 14. So this is also equivalent to 3 by 7. So basically 3 upon 7, 12 upon 28, 6 upon 14, all these are equivalent rational numbers. Now another question, how we can go from 12 by 28 to 3 by 7? So we have to multiply 4 with 3 to reach 4. So this means if we want to reach 3 from 12, we have to divide 12 by 4. So 12 divided by 4 would give me 3. And if I would divide the denominator with the same value 4, I would reach 7. So this also means that if I would divide numerator and denominator with the same value, and if it is divided very properly without leaving any remainder, then we would again get equivalent fraction. For example, if I would divide 6 by 14 by, let's say, 2, both numerator and denominator with 2, so 6 divided by 2 is 3, 14 divided by 2 is 7. So 3 by 7 and 6 by 14 are again equivalent rational numbers. So this is how we define equivalent rational numbers. So let me take one more example. Let's say that we have 4 upon 12. Now in order to get equivalent rational numbers, I can multiply this numerator and denominator with, let's say, 5. 4 times 5 and denominator 12 times 5. So this would give me 4 times 5 is 20 and 12 times 5 is 60. So 4 upon 12 and 20 upon 60 are equivalent rational numbers. What if I divide 4, let me write it here once again. So 4 upon 12, if I would, let's say, divide the numerator with 2 and denominator with the same value 2. So I would get 4 divided by 2 is 2 and 12 divided by 2 is 6. So this means 2 by 6 and 4 upon 12 are equivalent rational numbers. And not only this, 20 upon 60, 4 upon 12 and 2 by 6 are equivalent rational numbers. So finally, I would summarize this entire thing by just saying that if you would multiply a given rational number with same quantity, both numerator and denominator with same value, you would get another rational number that is equivalent to given rational number. And also I can divide both both numerator and denominator by a fixed value, and if properly divided, if that number properly divides both these numbers, then I would get another rational number which would be equivalent to given original rational number. So this is the concept of equivalent rational numbers, and I hope this is clear.